Testing, 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 testing. What I'm continuing to do is pick through this Ghpython computational book, which is pretty amazing, writing in Rhino script syntax with a little bit of highlights to Rhino Common, and I'm trying to translate it. So I have really gone in here and generated all of the scripts. I'm trying to get through chapter 1. I'm doing the best job I can. And I started with points and all of the scripts, converting them, no problem, into Rhino geometry, away from Rhino script syntax. I then went into vectors, and I think I had very little problem doing that. A little bit of trouble with Boolean outputs for scaling factors, and what was the other one? We'll see it when we get into the curves. And then I definitely was having trouble with the vector attractor points. I literally had to go in there and just kind of script what was going on, very interesting patterns and things within here, using the Rhino script, and I got that all up and running pretty good. And then I was using Rhino whenever I could. So it's nice to have gone back into curves now and played around with a few scripts in curves, curve domain, and divide curve. And that's actually what I'm going to take a look at right now is divide curve, and that should be fairly exciting to you. I've got it set up in black, so it's kind of fun. I'm going to take off everything but that script, so we're going to turn that to disable. Just so we're not even messing around with all these other scripts. When this file is said and done, I'll pick and choose what I actually want to put online as my own material. And what I'm going to do is go into here. I'm going to get rid of this plane because I don't technically need it right now. And we're dealing with a very simple curve, generating a curve with divide points and getting to the normal vector, which comes off of it. So it's a very nice little script, and I'll show you what it looks like and how I transferred it from Rhino script syntax into Rhino. So what I did was whatever I could actually, sooner or later, I want to be able to just hashtag this out and have the script still run, but you see it fails because I'm certainly dependent on Rhino script in a couple instances of that script. So it's generating the curve, the points, the normal line out, the points, and it's doing that from a curve that I inputted and reparameterized, even though I had to do that. I did that prior to pulling it in. So you're going to go in and you have to set up several lists. Divide points list, empty list, tangent line list, empty list, because you're not dealing in single data, even though you're bringing it in as single data, you're running it through loops, so it'll become more as you append it to those empty lists. And control point, or CP line, control point line empty list. And then what I'm going to do, and I think I'll just pull this up because we don't really need to be looking at this Grasshopper script anymore. Let's look at our full Python script. So we're leaving Grasshopper to get further in here. And what happens is they write the script for T and RS F range, and I find it's much easier to use for floats when it comes to ranges to use the RS, and I'll probably keep using that even though I've looked online to switch that over. And it's not that difficult, but it's simpler for me to just remember F or FX range function as an RS function, and it should work in either case. I'm going to create a point, and at that point, I'm not going to do it in Rhino script syntax. I'm going to generate that from Rhino geometry.curve.atPoint, and I'll grab the curve and I'll grab the t, which is the parameter along that point. So it's going to flow along there and make points each time I go through the start, end, and step as it iterates through those. I did have to start my domain, and I had to set my domain. I shouldn't get ahead of myself. Which I just did. The domain is set by setting the domain by getting value of the curve. So it's the first time I've got value from my screen, so I'm happy I'm doing that. Start point and end point will be domain 0 and domain 1, picking the list items. And then step will be, this is a simple formula to keep going through. You take the end point, you minus the start point, you divide it by the divided number that you want to choose, which is actually a slider going in, which I have set to, and this is where I do want my Grasshopper, because I want to show you what I have going on. Grasshopper, I do have the ability to slide that divide number to make different points within it. Okay, maybe I'll leave that up there. It's kind of small to see. It's not too much in the way, even though I do like seeing my whole script. Yeah, we'll take it up and do the whole script. Just taking a second because it's thinking. It's not liking me. There we go. It's fully extended. Okay, so then for T and F range, start, end, and step, you're going to create a point at using Rhino geometry curve at point, curve, and T being that parameter. Divide points will then be appended by those points. Now what they then did was they wrote what's in hashtag here unless it's hashtagged in Rhino script. So I was successful here in converting tangent of RS curve tangent at curve parameter t into Rhino geometry curve. And what you want to do is get in the habit of doing this, and this gets easier and easier. Tan equals, and you start remembering the paths you took. Dot geometry, tab it over, dot curve, and it comes up, dot tangent at. And so that's very similar because it didn't say tangent at in the RS, but it certainly leads me on the path. And then when I hit this, it tells me exactly what I need. You're going to need the curve itself, and you're going to need the T float, which is why I just put them in there as curve and float, and it works. So that's really how I'm going about generating those things. The next one was point tan equals RS at point add, and to add a point, you would go into Rhino geometry point 3D add and use the same data. So that's an easy switch. Tan line append. RS line is the exact same, Rhino geometry dot line, and you use the same data. So it's very simple to start. Here's where it gets a little tricky. Normal equals Rhino script syntax curve normal, curve T. And it's interesting switch of the normal directions. If I go on and I hashtag out this one, and it's kind of useless to do this because watch what happens. My normal directions actually switch up and they're all parallel, running down. But there is another interesting switch that I've noticed happens there is as I change my numbers, sometimes that normal jumps up. So I don't like that. That's a messy little script in Rhino geometry, and I'd have to have some fixins to make that appropriate that I actually want to use it. So what I'm going to do is keep that data there as if it somewhat runs, and I'm getting closer to it. And I don't mind not having total success. Keep it running as the one we had, which is right there. And then you can see the normal. I kind of got my head around this, but not quite. The normal is the RS vector scale, normal vector, and then 3 being the scale. But what I ended up doing was I ended up generating a transformation of Rhino geometry transform scale, which needs a plane and then its scaling factor. So I shrunk it by right down to 30% of what it was. And then I thought I could set the normal again to Rhino geometry vector 3D transform to that normal and to that trans. And I'm not having success with that because I'm ending up with a tuple coming out of here, and I have yet to figure out, but I'm getting closer to it. Moving right along, even though I got stuck on that and it was dependent on the RS, just like I still use RS in up in here where I was playing with just the F-range function. I'm okay to use both of them for now, but the better I get, the more I go on to the Rhino Common API and samples, I'm going to figure this out. And I know I am because every day I get a little better, and I just do this for a few hours every day. Actually, too many hours every day. I wouldn't mind having a mentor out there that wants to step in, and I'll probably get a mentor by the time I have to learn C# or go back to school for that, or take some night classes or do some online courses. There's enough online stuff that's happening that's very exciting for that, and I know the people I'm looking at studying under. So point normal, RS is just add the point, so that's the exact same thing. Add point add, same data, and normal line is an add line, so that's exactly the same Rhino geometry dot line, and then the same information. Good as teeth. I know that's loud. I apologize. Then we're going to get into the vector CP, which will create a Rhino script cross product. And the cross product is very easy. You go to Rhino.geometry, vector 3D, and dot, and cross product jumps right up, and you can use the same data again. So I really like this simple transition, and I have to start pretty simple like this to start, and then it'll get more and more complex. Here I had a little trouble with Rhino geometry on the unitized and on the scale. And even though the scale factor, I'm starting to think the same thing, get a transformation vector, and then at the plane, and I brought the plane in. I didn't even generate a plane. I actually brought the plane in, and that's why there's a little weird plane down here, because I was using that. It's quicker for me to just bring it into the node than actually script it into the node. So if I put that on preview, you'd see you're looking at a plane. And I like the blue, so sometimes I don't mind doing that. Building a plane is interesting enough, but you get into different outputs from Rhino script to Rhino common. And that's what can get really tricky. And obviously, you got to go into have to go into different namespaces besides geometry to solve these problems. And every time I ask a question on a forum online, I get these incredible fast answers that are still a little bit intermediate advanced for what I can handle. So I'm leaving this stuff as I slowly develop, but I'm still dependent on that vector scale and vector unitize. These give me true and false, and then of course that's not what I expect. I expect a vector and a vector, so it stops my script. Then the vector point, very simple add point, adding line, same thing, and then I'll do the output. So a nice little example of that. It's where my head's wrapping around it. I think other people have to start this way. If you're really going to move from Grasshopper into Python, you've got to start thinking of that, and you either could become extremely proficient in Rhino script syntax, but to me that would be the same mistake as getting extremely proficient and dependent on Rhino, or extremely efficient and dependent on Grasshopper or any of the particular plugins. And then getting stuck into RhinoScript syntax is going to keep you within these functions, but you're going to miss all these other methods and classes and libraries that can be pulled in from Rhino Common and its connection to, I think, the .NET and working in C#. And all these things I've been told seem to be the direction to go. And I'll tell you, as you walk through this path, it's not that the paths get more tricky. They're still the same meticulous type of answers, and your creativity has to be solved after you get the foundations of these things. But the forest gets bigger and bigger and bigger, and the paths are just more and more and more of what you can do. Well, I got a little 4-year-old screaming at me. It's not much of a script to look at, but it's certainly the way I'm going about this. So if you're interested in Rhino Ghpython nodes in Grasshopper, then link it to the Facebook group, stay and subscribe to my channel, and I'll take you guys on a trip through here. I'm starting to meet with international people that are saying, hey, you're really taking some leaps and bounds by going into this programming. And of course, those are pretty proficient C# programmers. So I know that I'm following somebody, and I know I'm following a place and taking a journey in where I want to go. Hopefully, I wish you well in your own efforts, and continue watching and supporting. Thank you very much.